In this video, you will learn what is a microservice. So, what is a microservice? Here's a definition I have found on Wikipedia. Microservices are a software development technique, a variant of a service-oriented architectural style that structures an application as a collection of loosely coupled services. In microservice architecture, services are fine-grained, and the benefit of decomposing an application into different smaller services is that it improves modularity. This makes the application easier to understand, develop and test, and it becomes more resilient to architecture erosion. It parallelizes development by enabling small autonomous teams to develop, deploy, and scale their respective services independently. So, microservice is first of all a web service. It is a web service that is small and it is responsible for one thing. For example, it is a small web service that is responsible for search functionality only. All other functionality that has to do with something else is implemented as a different web service. For example, password reset can be a different microservice, or email verification can also be a different small microservice that is responsible for email verification functionality only. It is also a web service that is configured to work in the cloud and is easily scalable. When breaking our large application and its functionality into small Spring Boot microservices, it becomes challenging to manage so many of them. And you need to have supporting environment that will help you maintain your system, that will help you scale your application and monitor all of these existing running web services. And Spring Framework provides a great supporting environment called Spring Cloud, which allows your microservices to run, discover each other, and it allows you to easier manage your architecture and monitor the status of your system. So if we compare microservice architecture to a monolithic application, it looks something like this. On the left side, we have a monolithic application, which can be a single Spring Boot application with multiple controller classes. Each controller class is responsible for one particular domain or a business capability, like, for example, working with users, or working with a product, or a search functionality. But all of these controllers are in one single Spring Boot application, and if you make a change to any of these controllers, then you have to rebuild and redeploy the entire application. If we look at microservices architecture, then here we have multiple smaller web services rather than one large monolithic web service. These web services are much smaller, and each web service is responsible for its one thing, for one particular business capability. One web service is responsible for working with user resource, like, for example, create and update user details, while another web service is responsible only to perform the email verification functionality. These web services can also be implemented in different programming languages and hosted on different platforms. For example, a user web service might be implemented with Java, Spring Boot, and Spring MVC. The addresses web service can also be a Spring Boot and Spring MVC web service, while the products web service can be implemented with gRC and JAX-RS. And search web service can be a web service implemented with PHP. I'm sure you're already seeing this big difference between the two approaches to build RESTful web services. In one case, it is one and very big web service built as single monolithic application, and in the other case, it is a set of smaller, fine-grained, and independently deployable RESTful web services. And each separate microservice can even be implemented with a different technology and deployed independently and run on a different server. Another very important detail to mention here is that since microservices are separate web services, they somehow need to communicate with each other. In monolithic application, we can simply import product class into a user service class and make use of it. In microservices, it is not always possible, as these microservices are separate applications and might even be implemented in different programming languages. So the way microservices communicate with each other is mostly via HTTP. Let's have a look at this diagram, for example. At the top of this diagram, we have two client applications. It can be a mobile device using our RESTful API, or it can be a web application working in a web browser. Both of these client applications communicate with our RESTful web service over HTTP by sending HTTP requests. And in the red box below, we have a Spring Cloud, which is an environment that supports the microservices we create with a Spring Boot framework. And inside of this Spring Cloud environment, the very first microservice that we see is at the top, and it is an API gateway, which is a standalone Spring Boot application. Then we have load balancer, we have config server, we have service discovery, which are also standalone Spring Boot applications that are built to serve a certain purpose. And below we have many other microservices that we have designed and built as small Spring Boot applications, each performing a specific business logic. One microservice is responsible for working with users, and then we have products microservice and checkout microservice and others. And all of these microservices, they communicate with each other over HTTP. For example, when a checkout microservice needs to generate a notification message, it will send an HTTP post request to a notification microservice, and notification microservice will do the rest. So if we come back to a question of what is a microservice, then these points which we have discussed in one of the previous slides should now make much more sense. A microservice is a small and a fine-grained RESTful web service, and when building microservices, you are following a certain architectural style. You are decomposing a very large monolithic application into a smaller microservices which are implemented as standalone web services, and each web service is deployed separately. You can update and you can redeploy each microservice separately as needed. And when one microservice is being redeployed, other microservices in your system are still up and running and are servicing client requests.